Okay, this is 5.3 on counting. Okay, so we're going to talk about something called basic regions briefly. They are the sectors of a Venn diagram, the various components. So if you have a very simple Venn diagram where we have one set and the universe, we would call this sector 1 and this sector 2. If you have a more complicated Venn diagram where we have two sets, we'll call this sector in here 1, this one 2, this one 3, and this one 4. Right? So there's 4 different sectors. You're not going to need to memorize this. This is just showing you what we mean by sectors. Right? They're just the different regions that exist. And then when you have 3 sets, you get even more sectors, right? Let's call this one 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 different regions when we have 3 sets, right? So basic regions just means one of the sectors of a Venn diagram. Okay, so we can use a Venn diagram and certain information about the basic regions to find information about the sets. And this is an example taken from the book to highlight this. Okay, let the set U be equal to all Nobel Prize winners from 1901 to 2015. Okay, that's a set of people. That's the universe. We're only going to look in the Nobel Prize winners. A is going to be a subset of the universe. It's going to be American Nobel Prize winners. C is going to be all of the chemistry Nobel Prize winners. And the years are the same for all of these. I'm just suppressing that for no real reason other than laziness. And P is going to be all of the peace Nobel Prize winners. Okay, so that's my universe, and that's the 3 sets I'm going to talk about. Let's draw a Venn diagram now. And what I'm going to do is I'm going to give you the numbers in this, the numbers of the number of things in each sector. So this is the universe. This will be set A, this will be set C, and this will be set P. This sector has 249. This sector has 69. This sector has 101. This one down here will have 26. This has 1. This has 0. And this has 355. And this part here has 99. Okay, so that's the different numbers that are in each sector. Now I can ask questions, and we can answer them by looking and adding up different sectors. So one question would be is how many Americans won a Nobel Prize from 1901 to 2015? Okay, we can answer that question, right? The Americans is set A. And set A, we can see, has 4 basic regions which make up set A. Right? I'll underline them here. We have this makes up set A, this is part of set A, this is part of set A, and this is part of set A. So we just add up those numbers. 249 plus 69 plus 1 plus 26. All right, when we do that, we get 345, which I know because I have it written on my sheet of paper, not because I did that in my head. So now we know that set A, the Americans, there's 345 Americans won a Nobel Prize from 1901 to 2015. Questions about how I did that at all? We'll do a few others like this from this set. All right. Okay, how many Americans won a prize in a field other than chemistry? Okay, a field other than chemistry. So we want them to be Americans, but we don't want them to be in the field of chemistry. So that looks like this number and that number added together, 249 plus 26. Right? That's 275. So 275 Americans won a prize in a field other than chemistry. Okay, now we're going to ask how many American Nobel Peace Prize winners. Scroll up to look at this picture again. Okay, so the Peace Prize is that bottom circle, and it intersects with the Americans in two regions. Two basic regions here, this 26 region and that 1 region. So that tells us 26 plus 1 is 27 American Nobel Peace Prize winners. I can think of 2. Can anyone think of a third? Maybe Herbert Hoover? I don't know. Okay. And then one more. How many total Nobel Prize winners? To find the answer to that, we have to add up all of the regions here. Each region, including the U region, right? Including the region of those 355 people that weren't American, that didn't win in chemistry, and didn't win a Peace Prize. We have to add up all of the numbers in that Venn diagram to answer this last question, and that total is actually 900 when you add them all up. Okay? We won't do that calculation, right? But you could sit there and you could add up all of the numbers that were in that picture. Any questions? Okay, let's look at another one. This is a data set we looked at before. U is going to be 500 top corporate presidents. S is going to be those with an undergrad business degree. And T is going to be those with a graduate business degree. And before, so the number of U is 500. The number of S is 238. And the number of people in set T is 184. Okay, now we're going to work backwards. From these 3 pieces of information, we're going to draw the Venn diagram and put in all of the numbers that belong to each of the basic regions. So our final for this one is going to be the starting point for the previous one. Let's draw the diagram. Okay, so there are 4 regions that we need here. We need to know, let's label them 1, 2, 3, 4. Okay, region 1 is going to be equal to the number of S intersect T. Region 2 is going to be equal to the number of S intersect T complement. 3 is going to be the number of T intersect S complement. And 4 is going to be S union T's complement, the number that's in each of those things there. Okay, so right now, I don't believe we have quite the amount of information to finish this problem. We need a little bit more. We need to know what's in S union T. And that's given to us as 310. Okay. So we don't have the 4 numbers we need, the number in region 1, 2, 3, and 4. We don't have those numbers, but we have a bunch of others numbers. We have this 500, this 238, this 184, and this 310. And now we got to kind of work backwards and puzzle and figure out what goes on here. Now, if you remember, there was this law that we studied that says the number of things in S union T is the number of things in S plus the number of things in T minus the number of things in S intersect T. This inclusion-exclusion principle. We know 3 of those 4 numbers, so we can find the 4th just through solving and using algebra now. S union T, we were told, is 310. S, we were told, is 238. T, we're told, is 184. And then this is the one we're looking for. So the number of S intersect T is going to be equal to 238 plus 184 minus 310. When you punch those numbers into a calculator or do your arithmetic, you get 112. So that means I can put 112 in that region. 112 there. Okay, now let's look at region 2. Region 2 is S, but without the things that are also in T. All right, region 2 is all the things that are in S, but are not in T. And this we can see right now. Okay, well, I know S is 238, but I know S and T is 112, so I could subtract that 112. And that will give 126 is in there. So that region has 126. Similarly, for region 3, I can take 184 and subtract 112. That leaves me with 72 in that region. Okay. And then the 4th region, well, that's the total 500 minus S union T, which we were given as 310. So this is 190. So this region 4 is 190. Okay. So we are given some of the information, not all of it, and then we got to go back and piece together what the other things are. Questions about that one? Okay, we'll do another one. In this example, an ad agency has 170 clients. 115 use television ads. We'll call those T. 160 use internet. We'll call that I. And 130 use mobile apps. We'll call that M. This is the 12th edition of this textbook, right? So probably in like the first few editions that M was an R for radio or something. But you know, this is they've really caught up with the times here and changed that R to an M for mobile apps. So it's nice how they're keeping it fresh, you know. Okay. 75 use television and internet. We would say that's T intersect I. 95 use internet and mobile. That would be I and M. So I intersect M. And 85 use television and mobile. That would be T intersect M. Okay. And then lastly, 70 use all three. That's T intersect M intersect I. Okay. Now what we want to do is we want to draw the Venn diagram and label all the regions appropriately. Okay. This one is a little bit easier than the last one, I think, even though there's three whole sets involved. That centerpiece that's in all three of them, we've just been told that that's 70. So we put a 70 right there, right? That one's given to us. Okay, but now look. Let's look at this region here. That is television and mobile, but without those that do all three. So television and mobile without those that do all three. Okay, so now I know what goes in there. What number goes in there? One want to impress their peers? No one wants to impress their peers. All right, well, I'll impress your peers then. You got 15 there. Look at that. You could be basking in the glow of all of your classmates' admiration right now. But you passed that up. Okay, well, you get another chance. Let's look at television and internet. Television and internet, but not mobile. That would be this region right here. We're told television and internet is 75. So what number goes there? 5. You're right. 5. Thanks, Alex. Okay, and then, of course, what number goes over here? Well, that's 95 is internet and mobile, but we take away the 70, so we get 25 there. Okay. All right, so we're getting there. We're working our way out from the inside. Now we want just television only. That's going to be 115, which is the total television, minus 5, minus 70, minus 15. So 115, that's minus 90 from 115, which is 25. So this is 25. Okay, how about just internet? That's going to be 160 minus 5 minus 70 minus 25. Well, that's convenient. That's 100, so that leaves 60. So 60 goes here. Mobile only is going to be 130 minus 70 minus 15 minus 25. Let's see. So that is, okay, so that's 40. That's 20 left over, I think. Did I do my arithmetic correctly? All right. My 5 hours of sleep didn't really hurt me. Not bad. Okay. I'm not done, though, because I haven't labeled what's outside of there, right? It said we had 170 clients. Are there any that don't buy ad time on television, internet, or mobile apps? Perhaps. Maybe these are the mysterious radio people that we have dismissed and left in the 20th century. I don't know. Or maybe they're just people that hire an ad agency but don't actually buy ads. I don't know why you'd do that, but how do we find that? Well, we take the total of the 170 clients and we subtract all of the different numbers in all the other regions. So we got to add 15, 70, 25, 5, 20, 60, and 25. And we subtract that from 70. Let's see, can I do this? Okay, so this is 85, okay, that's 95, 110, 115, 125, 185 plus 25 is 210. It's way too big. Right? That's way too big. It's way more than 170 clients, right? Oh, it looks like I have the internet only one wrong. Oh, that's why I miscopied the problem from the textbook. Okay, this is actually supposed to be 100. The only thing that changes is that this goes from 60 to 0 then, because 5, 70, and 25 added together is 100. So that means this number shouldn't be there. I'm sorry. I miscopied that number down. Okay, now let's add these. 15 plus 70 is 85. Plus 25 is 110. No. Yeah, 110, 115, 135 plus 25 is 160. That's 10. Okay, there are 10 people that don't use either of the three media for their advertising. The 10 radio diehards, perhaps. All right, so for the homework and in class, we just have a few minutes left, so I don't expect you to do all of these, right? But 26 through 30 was I was going to say in class, but let me now assign the homework too. It's 1 through 10, 39 through 44, and 54. Okay, so you're just kind of doing this process a few times from the information that they give you. So that's 1 through 10, 39 to 44, and 54.